Okay, so I'm back. Last time we were talking about curve sketching of parametric curves. And so we did that directly from the parametric equations, and we transformed the parametric equations into a curve written in Cartesian coordinates. So what I'm going to do next is flip that. We would like to parameterize a curve. So start with a curve written in Cartesian coordinates and develop a parameterization for it. And so we'll start with a couple of examples. In fact, that's how we're going to do it. So if we have a line y equals 2x plus 3, the easiest thing to do would be, say, to let x equal t. And then you can literally just plug in x equals t, and you get y equals t plus 3. There are no restrictions on x or y, so there are no restrictions on t. So our parametric equations are simply x equals t, y equals 2t plus 3. This is not the only possibility. There are infinitely many ways to do this, and but this is the easiest, in my opinion. What about y squared equals x plus 4? That's a little more interesting. Also notice that we have a restriction on our y values, so we got to be careful. So when I look at this equation, my mind just goes, if I let y equal t, everything is going to be super easy, right? Because what's going to happen? Well, then I'm going to get t squared equals x plus 4, which I can very easily solve for x, and simply get x is equal to t squared minus 4. Then I just have to deal with my restriction, but because y is equal to t, I very easily get that t has to be between minus 2 and 2, including, of course, the endpoints here. And so by parameterization here is x equals t squared minus 4, y equals t, and t is between minus 2 and 2 inclusive. Is this the only way to do the problem? No, not at all. Okay, let's do another example. So we want the complete curve, y equals x minus 5 quantity squared plus square root of x. So there are a few ways to do this. If I want to just be direct like I was in the previous problem, in the first problem, I could just go, hey, let's let x equal t. Then y is going to be, well, t minus 5 quantity squared plus square root of t. Now, I'm not exactly finished here, right, because there's a restriction that it's not written, but it's implicit, right? And what is that restriction? Well, very importantly, right, we see very importantly that hiding in here is that x is greater than or equal to 0. And so that means then when we go to here that t is going to be greater than or equal to 0. Right, so one possible answer is x equals t, y equals t minus 5 quantity squared plus square root of t, and t is greater than or equal to 0. Another possible answer would be, to say, gosh, I look at that and I don't like that square root. So I could let t equal x squared, or x equal, let me try that one more time. I could say let x equal t squared. Then y is going to be x minus 5 quantity squared plus the square root of t squared, which is x minus 5 quantity squared plus t. Ooh. Interesting. And then you might say, oh, swell, we got rid of those restrictions on t. No, we really didn't. Right? Because to get the square root of t squared equals t, we still require t has to be greater than or equal to 0. So we didn't lose it. It came with us. So t still has to be greater than or equal to 0. And so the answer with this approach then is x equals t squared. It also would have been nice if I'd put the t squared in there instead of x, but sorry about that. X equals t squared, y equals t squared minus 5 quad e squared plus t. 0 less than or equal to t less than infinity. So this is another possible answer. Okay, so piecewise linear path. All right, so that means that we're doing, so we have PQ followed by QR. So one thing we can do is just find the equations of those lines. And so I would start with this. So PQ, what's the equation on that line? So my slope is -4 minus -2 over -1 minus -2 is going to be -2. And I get y minus y1, so let's say -2 is m times x minus, well, x1. So I get y plus 4 is -2x. 2 minuses make it -4. So let me just double check that. So that gives me y is equal to -2x minus 8. And QR, my slope is 4 minus -4 over 0 minus -1, which is 8. And let's see, y minus, let's say -4 equals 8 times x minus -1. Y plus 4 equals 8x plus 8. So y is equal to 8x plus 4. Unless I made a mistake, but don't think so. Okay, so we have two possibilities. We could do both of them at the same time, or we could parameterize them separately. That's a possibility. There are multiple possibilities. So, for example, if we parameterize separately, right? So I could do PQ first. So I would let x equal t, if I want to do the same thing. And then y is going to be -2t minus 8. And that would be x going from -2 to 1, so t goes from -2 to 1. Right? And again, that came from the fact that I'm going from p to q. So I have -2. And then QR, well, if I do the same thing, if I let x equal t, then y is going to be 8t plus 4. And here, what is t going to be? Here, we have -1 to 0. So we have -1 less than or equal to t less than or equal to 0. So those are our parameterizations. and we can combine them into one. Really, we could say, you know, x equals t, y equals negative 2t minus 8 if negative 2 is less than or equal to t is less than or equal to negative 1, and 8t plus 4 if negative 1 is less than or equal to t is less than or equal to 0, which is really what we have. Alternately, so that would actually be the answer. As an alternative, oops. Alternately, some authors suggest letting x equal x naught plus at, y equals y naught plus at. I don't, you know, necessarily see that as a necessity because we were very easily able to get the answers, and so that's kind of where I see it. So in the next video, I will be discussing the calculus of parametric curves, so differentiation and integration. So that should be fun, and this is great prep for Calc 3 for multivariable calculus. Besides being kind of an interesting topic in and of itself, as I sort of motivated in my first video on this stuff. Anyway, that's it for this one. Have a good one.